বিভিন্ন শাখার আবিষ্কারের গতি বাড়িয়ে দিচ্ছে। প্রকৌশল নকশা থেকে শুরু করে জলবায়ু সহনশীলতা, স্বাস্থ্যসেবা, পানি সম্পদ ব্যবস্থাপনা এবং টেকসই উন্নয়ন সব ক্ষেত্রে এআই গবেষকদের জটিল সমস্যার সমাধানে নতুন সক্ষমতা দিচ্ছে। বাংলাদেশের মতো একটি দেশের জন্য এটি বিশেষভাবে গুরুত্বপূর্ণ। সাস্টেইনেবল অ্যান্ড ইনক্লুসিভ ডেভেলপমেন্টের পথে এগুতে হলে পানি, জ্বালানি, পরিবেশ, কৃষি, অবকাঠামো এবং শিল্প উৎপাদনশীলতার মতো খাতে উদ্ভাবনী সমাধান প্রয়োজন, যেখানে এআই গুরুত্বপূর্ণ ভূমিকা রাখবে। আইআইটি বুয়েটের পরিচালক এবং আয়োজক কমিটিকে এই সময়োপযোগী অনুষ্ঠানের জন্য আমি আন্তরিকভাবে অভিনন্দন জানাই। আসুন আমরা শিক্ষা, গবেষণা এবং উদ্ভাবনের মাধ্যমে কৃত্রিম বুদ্ধিমত্তার সম্ভাবনাকে দেশের কল্যাণে কাজে লাগাই এবং একটি জ্ঞান ভিত্তিক, প্রযুক্তি নির্ভর ও টেকসই বাংলাদেশ গঠনে সম্মিলিতভাবে কাজ করি। আপনাদের সবাইকে আন্তরিক ধন্যবাদ। ধন্যবাদ
স্যার। ধন্যবাদ স্যার। চলে যাবেন আমরা জানি। আমি এই মোমেন্টটাকে আমি একটু কাজে লাগাতে চাচ্ছি। আমি আমাদের চিফ গেস্ট মহোদয়কে রিকোয়েস্ট করব আমাদের চেয়ারপারসনের হাতে আজকের প্রোগ্রামের ক্রেস্ট তুলে দেওয়ার জন্য। আমাদের চিফ গেস্ট মহোদয়কে রিকোয়েস্ট করছি চেয়ারপারসন মহোদয়ের হাতে ক্রেস্ট তুলে দেওয়ার জন্য। মাননীয় ভাইস চ্যান্সেলর স্যার চলে যাচ্ছেন, সো আমি ভাইস চ্যান্সেলর স্যারকে রিকোয়েস্ট করছি অ্যাজ এ চেয়ারপারসন অফ দিস ইভেন্ট আমাদের চিফ গেস্ট মহোদয়কে আজকের ইভেন্টের ক্রেস্ট হাতে তুলে দেওয়ার জন্য। অনেক অনেক ধন্যবাদ স্যার আপনাদের দুজনকে। এখন আমরা আমাদের মূল অনুষ্ঠানে ফিরে যেতে পারি। আমাদের আমি প্রফেসর তাসিনাকে আমন্ত্রণ জানাচ্ছি।
Ladies and gentlemen, the central feature of today's seminar is the keynote lecture by our distinguished academic, researcher, and thought leader, whose contributions have significantly influenced higher education, engineering, and technological advancement in Bangladesh. It is my honor to introduce our keynote speaker, Professor Dr. Rafiqul Goni, distinguished adjunct professor at IIT Buet. Professor Goni's remarkable academic journey and contributions to science, engineering, and innovation have inspired generations of scholars and researchers around the world. Today, he will share his thoughts on education, research, and development in the AI era. May I now respectfully invite Professor Dr. Rafiqul Goni to deliver the keynote speech.
Okay, so thank you very much for the kind introduction. I would also like to thank the chief guest, the chairperson, the special guest, and also Dr. Mohit Saman and his team for organizing this special event. I'm going to talk about education research development in the era of AI. I apologize a little bit that I have some problems with my leg, left leg and right hand, so a little bit handicapped. That will make me finish faster also. So let me start with what I would call a positive contribution of science and engineering to modern society. We humans are, I think nobody will dispute that, are the master of planet Earth. And the question is, what should we do to remain at the top? An example of the challenges that we are facing, if you see the products on the right, all around, these are the products that help us to remain master of planet Earth. And we use the resources, the available resources on Earth, to convert these resources to the products that we need for our sustainability. And the resources that you see are naturally occurring resources. It does not include human resources, which I will highlight quite a lot in my lecture. But these resources are not uniformly distributed over Earth. Some places have some resources, others have other resources, but they specialize on those resources to keep their status as high as possible. So the challenge is then, what should we make, how should we make, where should we make to address the sustainability of our society on Earth. And also you can say in Bangladesh what we should do. And what you can say is that we need to learn to develop techniques that will help us to find not only the products that you see, the manufacturing systems that are needed for them, the services that they will be providing. We need to learn how to develop them, how to identify them, so that we can stay at the top. And one of the challenges that we are facing currently is related to water, energy, environment, food, and the interactions related to health and environment. And it's not a simple challenge. If we look at the population on Earth and in the next 30 years, we can see that the population may stabilize around 10.5 billion. Good thing is that it will be less than 11 billion according to predictions. But this means that the global GDP needs to increase by 6 to 7 level from the current. The production capacity for commodities like steel, chemicals, timber, etc. need to increase 5 to 6 times. Energy demand will increase by 3.5% amount compared to now. Electricity demand 7 times more. There will be more water demand, more greenhouse emissions. So how do we address this to accommodate the population that will be increasing and that will also maintain our sustainability? The decisions therefore we make related to all these issues have some effect, and we can see this effect. These are pictures from, unfortunately, Bangladesh, and these are not natural disasters. These are man-made or human disasters related to water pollution, related to building construction which had failures, and so that if we look at all of these, this data on the bottom right is from last year. Bangladesh was, at least according to this data, the second highest air polluter in the world. What can we do to improve that? Also, the pollution is caused by transportation, emission that comes, but the one picture below looks a very clean road with almost nothing in there. That is actually the result of COVID. Because of COVID, we had very nice clean roads, no transportation problem. So everything has a good and a bad effect. What can we do to improve this? So what do we do about the challenges we are facing on Earth? We can wait for a miracle, but I think we should do better than that. And this is a quotation from one of the professors at Buet. And she said that today's solutions that we are looking for may be tomorrow's problems, and the apparently successful venture may end up in regrettable substitutions. And there are many examples in the world that can be seen. Refrigerant is one. We find better refrigerant only to find out that it is not actually that good. Similarly, long-term product, we want products that last long, but if we want to get rid of it, there are problems. We cannot decompose that. If we look at carbon capture sequestration, should we cure the problem or should we prevent the problem? Because we are at this moment trying to cure the problem, which is much more difficult than to prevent the problem. Why are we using so much energy so that so much CO2 will be released? Industrial success, increased development causes water pollution. We need better water and waste management. The pollution is caused by chemicals and other waste, but why is the waste coming to water? That also needs to be looked at. And one of the unfortunate things is about the drones. Drones had a very social and health-related requirements, and it was doing very good job. But now it is being used to fight proxy wars, which is a really bad development. What can we do about that? So this lecture is about how to tackle some of the challenges we are facing on Earth in the era of computers and AI. So one thing is, can we turn the challenges into opportunities? What we are currently facing is on the left, and this is not from Bangladesh, it's from the world. And what we want to do is, if we have a negative effect, like in COVID, number of people dying or amount of CO2 that is being emitted or amount of water that is being polluted, all those effects are the curve, the gray curve. And if that goes above a certain limit, we have disaster. So what we need to do is to press that gray curve down to the level of green, so we have everything under control. And so if we can do that, then energy, water resources, food, health, we will come to the situation that we would like to be. So now we come to the main things that I wanted to highlight: education, research, development. The way I look at it, all of these directly or indirectly solve problems. So in education, among the different things, the outcome is that we train the students to learn the theory, to learn the principles, to understand the method, so that they can apply this to solve practical problems in the classroom and afterwards when they go to work. In research, all those methods that have been developed, they can improve them and apply them to find new solutions that give better results than the current ones. So we want to improve them. but at the same time, we want to also find novel solutions. So that's where the research is. It is also solving problems related to similar topics. And development, if we find multiple solutions of problems, which one are we going to use to develop our society? So we need to find out among the different alternatives, which are the best ones that we can use for our society. So all of this relates to that we can solve all these problems with what we call a systems approach or a systematic method to solve the problems efficiently, reliably, and very fast. So I will give a brief introduction of what is systems approach. It is also called process systems engineering. So process systems engineering started actually quite late, about 1988. It is all about the development of systematic techniques for problem solution. Doesn't matter which kind of problem, it has to be in a systematic way. And if we approach a systematic way, we would be able to not only solve the problem efficiently, reliably, and rapidly. How do we do that? We formulate the problem, which can be synthesis, like generation of alternatives, which can be design, like evaluation of the alternatives. We can control, operate all these problems. We can formulate them mathematically or some simplification of it, and then find an effective algorithm so that we can solve it. So already you can see that we need data, we need knowledge, we need algorithms. These are all related to problem solution and artificial intelligence. And we will see how they are connected. So what is important here is that we have a system that is the problem we want to solve with a well-defined boundary. So the boundary could be Bangladesh, and then there will be subsystems, water subsystem, energy subsystem, health subsystem, and so on. We can try to collect the data, understand the system, understand based on the understanding, do the model, do the design, and then optimize solutions that could be beneficial to society. Now, what is the connection of this with artificial intelligence? Artificial intelligence basically started around 1983, around the same time as process systems engineering. It is the study of how to make computers do things at which, at the moment, people are better. But what is the objective of artificial intelligence? The goal is to make machines, that is computers, need to be trained by humans to solve problems faster than humans and have the ability to find new solutions of interest by covering search spaces that humans cannot cover. So the question is, can machines trained with AI techniques would eventually end up doing all the things that humans can do and do them better? That is, AI could help us to find machines that are superhuman. And then I will raise this question now and we can discuss it afterwards. So already you know that computers with IBM, DeepMind, they can beat humans in chess, all kinds of games. The computers can do much better, can co-pilot or autopilot planes at certain operations of the plane, drive cars automatically, and can do many things. But the question is, can we design or can AI design and operate a chemical plant? Or can AI design a car that will run or a plane that will fly? At this moment, it cannot. And the reason it cannot is that those methods that can be used to develop these need to satisfy certain engineering principles. And those engineering principles cannot be satisfied in the current state of AI. And we will talk about that also. So maybe in future it can, but at this moment it cannot. But it can do still a lot of things. So, what are the things it can do? It can do increased data handling methods. Humans can maybe analyze data in 2 dimensions. AI or computers supported by AI can analyze data in multiple dimensions. That has significance in diagnosis of health, in looking at how accidents happen, and many other things. In image processing, those analysis techniques can help. Language models, one of the reasons if you use ChatGPT or Gemini or all of these is that they have collected all the published data into what is called the LLM or large language model. And then any question one asks, it will use the model to predict the answer. But it does not give an exact solution, it gives a stochastic probability solution. If you like to go to a restaurant or read a book, you can ask, what book should I read? And it will give you an answer. But if you want to design a chemical reactor, and the probability of temperature that you need is 400 plus minus 50 degrees, the reactor will explode. Similarly, the plane will not work, the plane will crash, the car will crash. So for those reasons, those LLMs can do a lot, but still there are some things it cannot do. And I think we see this. This is just to indicate that if you see on the left, the blue circle, that is what the current techniques can do. But if we combine the current techniques with AI, we can cover a bigger. And if we combine current techniques, AI, with social dimensions and other disciplines, we can cover even a wider range. So that is where we should be going by combining all these things together. So I talked about that, the kind of problem we can solve. One is called synthesis, but in general terms, synthesis means generation of alternatives. If I want to build a car and I have an assembly plant, what would be the sequence of operations and what tools and what equipment we need in order to build that car? So that would be the generation of alternatives. How many alternatives are there?